Hello and welcome back. I just waved my hands in front of me like you guys could see me. So today we are going to be working on 2.3, that is chapter 2, section 3, modeling with linear functions. So this is about those like really bulky word problems that just like drag on and on. This is mainly about how to break them down. So the first thing that is going to be important here is identifying the steps of problem solving. Ooh, spelled that wrong. Okay, the first step is you are going to identify what is changing and what needs a variable. You're not going to assign variables any values at this point. We're going to do that later. So you're just going to set them equal to something. For example, if we were talking about, let me think of one. I don't know, if we were talking about gallons of milk or something, and you wanted to say X equals gallons of milk, right? Then that would be it. So we're just identifying the variables that we need right now so we can make sure that we don't really leave any out. This is also a good time to sketch a picture or diagram of something that you want. I always like to sketch pictures because math can be kind of boring. We don't get to draw a lot of pictures that aren't geometry related in math. So now what you're going to do is you're going to reread the problem to provide some type of value to our variables and identify what we don't have. So identify maybe what we don't have. So our third step, we're going to determine what we are being asked to do. And you may think, wow, gosh, this is like a really obvious step, right? But I can't even tell you how many times students, even myself, have not actually answered the math question that is being asked. It happens all the time, trust me. Now we're going to try to identify a path to the answer. So that means like defining anything, define any words, stuff like that, things that would help us get from what we have to what we need to know. And then we are going to solve the problem. That's the right, I wrote it out so easily, but that's the big step. And then you're going to determine if it is reasonable and what it means, because those are very important. In the real world, when you solve a problem, like if you're a bridge engineer, you can't just be like, wonderful, the answer is like 36 degrees. And just assume that everybody knows what that means, because chances are 99% of the people you encounter will not know what that means. So that's very, very, very important. So now we're going to build a model. So let me see. So let's say they've got a good example in the book. I'm going to go with the example. Let's say Emily saved, I'll make a number up. Oh, here, $3,500 for a trip. she will be spending $400 a day for room, food, and entertainment. If she only has, I don't know, let's say she only has $10,000. How long can she stay? That is the question. So we're going to identify what's changing. So it looks like her dollars are going to be changing. And then her days are going to be changing. So we will let X equal days. And since the dollars depends on the days, I will let Y equal dollars. So now what we're going to do is we're going to go and reread, and we're going to provide variables for our values and maybe identify what we still need. So here, X equal days. Notice that is what we are trying to find. Y is actually going to be equal to a linear equation, if you did not notice that. Because it's a function, right? The amount she is spending is depending on the days. So that the amount she is spending is our slope. So our slope is the amount she is spending per day. That means M equals 400. Okay, so now we need to identify our B. B is the y-intercept, which is how much she is set outright to spend. So even if she only starts, if she stays, let's say $0, she goes on the trip and comes home, stays for 0 days, she had to spend $3,500 for airfare. I'm going to go through and label these. Oops. Okay. This is B. We've gone back and provided values. So C, we're going to determine what we are being asked to do. We need to find the number of days she can stay, given that she only has $10,000. So that's what we need to find. Days is X. So we're going to be trying to solve for X. Now identify a path to the answer and define any unknown words. So for D, in terms of identifying a path for an answer, I know I'm going to have to build a linear equation. Now with what I have, I can have y equals M is 400 and the y-intercept is 3,500. So this will tell me how much money Emily is spending for X amount of days. Now we need to find out when y equals 10,000. and we'll see what that is. So going up to, now we're on step E, we are going to solve. So we need 10,000 equals, we'll make this a math equation, 10,000 equals 400 x plus 3,500. Then 400x is going to equal, let's see, 9, 10, 6,500. And now when we divide that by 400, x is going to equal 16.25 days. We can round down because a hotel won't let us stay 0.25 days. I don't really even know what that means. So we would round down no matter what it is. Even if it's 16.9999, we would still round down to 16 because there's that small portion of that day that she would not be able to pay for. So is this reasonable? This is reasonable. She would be able to stay for quite a while if it only cost her $400 a day. It means that Emily will be broke after 16 days. And she'll have to come home. All right. Now, what else do we need to cover in this chapter? We've learned how to build a function. Distance walked. Let's try this one. So we're going to build a system. So we have 2 truck rental companies. The first, Keep On Trucking, charges an upfront fee of $20 and then 50 cents a mile. So truck 1 is a fee of $20. And how much per mile? 59 cents a mile. Truck 2 is going to cost us a fee of $16, and then it will be 63 cents a mile. Now, when will the first truck company be a better choice? Let me capitalize that one. When will truck 1 be a better choice? So the first thing we're going to do is we've read the problem, what needs variables. So it looks like we're going to be building a linear system here. So we're going to have 2 linear equations. So slope 1 will go with truck 1. And what do we think slope 1 is? It is that 0.59. Slope 2 will go with truck 2, and it is the 0.63. That is because for every 1 mile we go in X, you will go up 0.63 in Y, which is cost. So for every 1 mile you go up in cost. So that's why those are the slopes. Now, what do the y-intercepts represent? The y-intercepts represent any fees or costs that are automatically associated with doing something. So here you will have y-intercept 1, which goes with truck 1, and that's 20. And then you will have y-intercept 2, which goes with truck 2, which is 16. So now I have y equals 0.59x plus 20 and I will have y equals 0.63x plus 16. And those are my two equations. So now, what am I looking for? I'm going to go and find that. What am I being asked? I'm being asked, when will truck 1 be a better choice? So when will truck 1 be less expensive than truck 2? So remember, we need to find when they cost the same, because when they cost the same, if you move even a decimal in either direction, they won't cost the same. So that's where we're going to determine our break-even point, to where they cost the same, so that we can determine when one costs more, if that makes sense. Let me see if I could draw that. So this is a break-even point. We need to determine this point because anything on one side of the break-even point will cost more than the other things on the side of the break-even point, if that makes any sense. I hope it does. We will set them equal to each other. So that means we are going to have 0.59 x plus 20 equals 0.63 x plus 16. Then we can see that, oh, decimals, hold on. Then we're going to see that when we take over the 0.63, we're going to get negative 0.04 x is going to be equal to negative 4. We will divide both sides by negative 0.04. And that gives us, divided by, that gives us, whereas x equals 100. What does this mean? Is it reasonable? So this means that when we drive 100 miles, I'll put it that way, when we drive 100 miles, both trucks cost the same. So we're going to want where truck 1 is, let me see, truck 1 is cheaper than truck 2. And that will be, let me see. We will graph this. Let's go ahead and graph this. All right. Let me go to Desmos. I don't want to introduce an inequality sign or anything and confuse anyone. Okay. Here we go, and we will have 0.59x plus 20. We'll call that one f of x. And that is truck 1. And truck 2 will be h of x, and that is equal to 0.63x plus 16. All right, so we want to know when truck 1 is going to cost less than truck 2. And we have determined that here they intersect at 100. Now, if truck 1 is the red line and truck 2 is the blue line, when we talk about being more expensive or less expensive, if you go beyond this break-even point right here at 100, if you go beyond that break-even point, do you see how the blue line is on top? Being on top means that it is going to be more expensive than the red line. The red line is truck 1. So after we hit 100 miles, truck 2 is going to be more expensive than truck 1. Okay, so what does this mean? When we drive over 100 miles, and we learned this from the graph, truck 1 is less expensive than truck 2. And if you need Desmos to graph anything, go right ahead. In the real world, you will have lots of tools available to you for you to do these things. Your boss is not just going to hand you something complicated and say, hey, can you do this on a piece of paper? So as long as you understand the concepts and what being above that break-even point means and below that break-even point, and what it means for one line to be on top of another line in terms of costs, that's okay. Desmos is a great tool so that you can focus more on what the graph means and not how to graph the function itself. So this concludes 2.3. Now 2.3 is going to be a hard one. Some of the questions are probably going to be difficult because this is more of a chapter where you have to just solve lots of problems on your own and just see what works and what doesn't in terms of like identifying the variables correctly, giving the values correctly. This is more of the bulk of this will be on you guys. So our next video will be fitting linear models, and that one should be pretty interesting. So I will see you next time.